Here's a second example, a little bit more complex with this one. The numbers aren't as nice and clean as they were in the last one, and this is an example of why graphing is not always the best method. But the same idea here, right? I can take these two equations, because they're both equal to the same thing. I can set them equal to each other. That's called the transitive property, I think. I don't know. Doesn't matter. So I can say that this thing x minus 4, because it's equal to y, and 6x minus 10 is equal to y, those two things must be equal to each other. So I can make an equation. The x minus 4 is equal to, it's equivalent to 6x minus 10 at the point where they intersect. So let me solve this. Let me think about moving those x's first. Which one would be more beneficial? Think ahead a couple of steps, like I always say. I think I'm going to move the x first. So I'm going to subtract x from both sides. That's minus 4 equals 5x minus 10. Now I'll add the 10 to both sides. Plus 10 gives me 6 equals 5x. So this one's not going to come out to be a nice integer value. I'll divide by that 5. And I get x equals 6 over 5. So 6 over 5, not an integer value. I could give that as a decimal if I wanted to, but sometimes these come out sloppy. And that's okay. What we want to do then is find out the other value. Remember, at this point, we've only solved for x. We now need to solve for y. I got for y, for this problem, I got y equals negative 14 over 5. See if you can get that for yourself. Check my work. I could be wrong. Another way to write that again is 6/5, comma, negative 14/5. And again, I would accept this as decimals or as mixed numbers if you wanted. 1 and 1/5, negative 2 and 4/5. Those are both okay as well. Check my math there. Make sure I am correct. See if you can find that same value for y.